All right, we're gonna look here on page 25 for our notes today, and you should have a piece of paper like this. You can go ahead and cut that down the middle, okay, and then you can give that to somebody else. You only need half of it. And then the other thing you're going to do is you're going to cut along each one of these lines to here. And we're going to actually fold it on this line. I already have some writing on here. Just ignore that for now while I walk you through this. But you're going to cut along each one of these lines, and then you're going to tape it at kind of the right here. I got a piece of tape, and then down here I have a piece of tape. So you'll tape it in both of those spots. Okay. If you need to pause to do that, do it. I'm going to go ahead and keep going through the video. Just pause as you need to. Let me go ahead and zoom in because I already have all this written down. So this might be helpful. So we're going to talk about some properties that are going to be very beneficial for us as we move into geometry proofs. These top three properties that we're going to first look at deal with equality. Okay, so anything with an equation, or congruence, so anything with the congruent sign. It would be reflexive property of equality if it has an equal sign, or reflexive property of congruence if you're using the congruent sign. So what the reflexive property is it means anything can be equal or congruent to itself. Okay, so two examples here are AB equals AB, so lengths of segments. Those can be equal to itself. And then if we use congruence, we can say segment XY is congruent to segment XY. So anything can be equal to itself or congruent to itself. And that's the reflexive property of equality or congruence. Just like when you look into the mirror, you see your reflection and you are equal to yourself. So that's why we use the reflexive property. Again, please pause if you need to get more of that down. The symmetric property, again, of equality or of congruence. The symmetric property is when two things are equal or congruent, you can flip the order, or you can rewrite them in a different order. Some examples we have of that are if segment AB is congruent to segment XY, I can change the order of that. I could write segment XY congruent to segment AB. If we look at some equations, the measure of angle ABC equals the measure of angle XYZ. I can flip these two end parts around and write it the other direction. That's the symmetric property. You also see it here. Let's say you write something like somebody writes x equals 5, but instead you write 5 equals x. Well, that's the symmetric property, being able to write it either way. It's the same thing. Okay, so this one over here was of congruence, so symmetric property of congruence. This one over here, symmetric property of equality. My favorite property is the transitive property, and this one can be rather fun or puzzling, one of the two, as it is a linking property from one thing to the next. Okay, the transitive property cuts out the middle information and forms a new statement. Okay, so here we're going to say if angle ABC is congruent to angle XYZ, and then angle XYZ is congruent to angle PHS, then I can say these outside two things are congruent. Okay, so angle ABC is congruent to angle PHS. Here's kind of a real simple one with equals. If A equals B and B equals C, then A equals C. Okay, it's a linking property. We can link multiple things together. Okay, I could go through 10 different things here, linking them all together, and then at the end, if the first one is going to equal the last one. Okay, it's a linking property. That's the transitive property. Okay, the last two laws, or the only two laws, are law of detachment and law of syllogism. Now, we don't use this vocabulary very often because we use some other things. When I kind of talk you through law of detachment, it's kind of the duh law, and law of syllogism is actually the same thing as the transitive property. But these two laws are more on the logic side of things and the written sentence side of things. So law of detachment is if the hypothesis is true, then the conclusion is true. Okay, so if my beginning statement is true, my end statement will also be true. Okay, so let's just say that if you wash a shirt, or the shirt will shrink in hot water. Okay, you have a shrink and you know, or you have a shirt and you know it will shrink in hot water. Okay, that's a known fact. Okay, it's labeled on your shirts. Then here's kind of the problem. If mom washes your shirt in hot water, then what's going to happen? Well, by the law of detachment, this first part is true, okay, meaning it's getting washed in hot water, okay. You're going to have a shirt in hot water, then it's going to shrink, okay. The law of detachment says it will shrink based on this rule right here that we outlined at the beginning. And like I said, this is kind of a duh thing. If you know it's a fact and then it's true, the conclusion is also going to be true. That's what this is saying. Okay? And law of syllogism is the transitive property. This is a linking law, same as transitive. Again, we look at it more as if it were sentences. So if it's cold, then it snows. And if it snows, then it sticks. Well, we can conclude here, cold snows, snows sticks. That if it's cold, it's going to stick. That's what we can conclude. Very simple there. These don't have to be true, real life things. Okay, it could be anything that I can link together. Let's say, let's just say if red, then 5, and if 5, then upside down, then we can conclude if red, then upside down. Okay, it can be random things, okay, but you're linking it together. Red, then 5, 5, then upside down, then your red is going to be upside down. That's a law of syllogism or the transitive property. Doesn't matter. The last thing we're going to talk about here is called a counterexample. And counterexamples are very, very useful in proofs. If I'm trying to prove something works for everything, I have to go through and prove it for every little bitty thing. But we can also disprove something by one little counterexample. Okay, so a counterexample is a specific case for which the conjecture is false. Okay, so here I wrote a conjecture, 2x is greater than 10. We could assume that that's true for everything, except I have found a counterexample for when it's not. -5, if x is -5, this thing is not true. okay? Because 2 times -5 is -10. -10 is not greater than 10. This is a counterexample. This disproves this going on, okay? So I know when you're in arguments with friends or family members or whatever, you try to think of a counterexample to prove them wrong. Well, it usually starts out with, well, you didn't do it during this time, or you didn't do it here, or you didn't do it for them, or something like that. That's a counter example proving them wrong. Okay. So you're going to have a worksheet for this lesson over these properties, okay, and using them. And then you're going to take photos of that worksheet and put it onto Schoology for grading. Okay, so there's nothing in big ideas for this one. It is a worksheet. Again, rewatch the video if you missed some of those note-taking things. And if you have questions, feel free to reach out.